February 20th, 1943, north of the Kasserine Pass in Tunisia, dawn broke over a battlefield that would leave seasoned German tank commanders deeply unsettled. What they witnessed that morning never translated cleanly into after-action reports or doctrinal language. It felt wrong. Through dust clouds kicked up by maneuvering armor and the oily smoke of burning vehicles, American M4 Sherman tanks appeared to move with an almost unnatural coordination. 5 Shermans, broken apart by folds in the terrain and separated by ridgelines that denied any line of sight, converged on German positions with timing that seemed impossible. There were no signal flags snapping in the wind, no flares arcing overhead, no dispatch riders racing between vehicles. Yet the tanks advanced as if guided by a single nervous system, each one instinctively covering ground the others could not see, each crew seemingly aware of where the rest were positioned. Inside German Panzer IVs equipped with Fug 5 radios, commanders struggled simply to hear their own company leaders. Static flooded their headphones. The crackle and hiss of amplitude-modulated transmissions overwhelmed voices until orders dissolved into noise. The Fug 5's 10-watt transmitter, considered advanced by late 1930s standards, could rarely maintain clear contact beyond a few hundred meters when tanks were moving. Worse still, most German tanks carried only receivers. They could listen, but they could not speak. They could not report what they saw, warn of threats, or call for support. What the Americans were using that morning was something that German crews did not yet understand existed in practical battlefield form. Every Sherman carried a frequency-modulated radio, every single one, crystal-controlled, transmitting at 25 watts and delivering clarity that sliced through engine noise, vibration, and chaos like a blade through cloth. Nearly 8,000 kilometers from Detroit assembly lines, the most decisive technological advantage of World War II was revealing itself. It was not thicker armor or a larger gun. It was invisible electromagnetic waves linking American tank crews together into something the Wehrmacht had never imagined. The battlefield was no longer a collection of individual vehicles. It was a network. That transformation did not begin in Tunisia. Its roots reached back to July 22, 1941, when the United States Army standardized a family of radios, the SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces were advancing deep into the Soviet Union using armored tactics that depended on radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were quietly perfecting a technology that would render German systems obsolete. The engineering team included Daniel E. Noble, who grasped that frequency modulation could be adapted for mobile military use, and Henryk Magnuski, the brilliant RF engineer who solved the brutal technical challenges of making sophisticated electronics survive heat, dust, shock, and vibration inside a tank. Their creation weighed roughly 180 pounds and turned every Sherman into a fully connected node in what was, in effect, the world's first armored battlefield network. At the heart of the SCR-508 was the BC-604 transmitter, producing 25 watts of output power, more than double that of the German Fug 5. Operating in the 20 to 27.9 MHz range, it offered 10 preset channels held precisely in place by quartz crystals. Paired with it were 1 or 2 BC-603 receivers, allowing commanders to monitor multiple nets simultaneously. This mattered more than German analysts realized at the time. A Sherman commander could listen to his platoon while remaining in constant contact with company headquarters, never losing situational awareness. But the real revolution lay not in wattage or channel count. It lay in frequency modulation itself. Edwin Howard Armstrong's FM technology, licensed for military use, fundamentally changed radio performance. Unlike AM modulation, FM ignored most electrical noise. Where German radios faithfully amplified every spark plug discharge and track vibration into static, American FM sets delivered clear voice communication even under artillery fire. The battlefield was electrically hostile, but FM simply did not care. When American armor arrived in North Africa during Operation Torch on November 8, 1942, these radios went with them. Tanks of the 2nd Armored Division landed near Safi and Fadala, carrying SCR-508 sets that would soon demonstrate their superiority. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, operated under severe communication constraints. A standard German tank platoon of 5 vehicles typically included only 1, sometimes 2, with full transceivers. The rest carried Fug 2 receivers only. They could hear orders, but they could not answer them. German armored doctrine compensated through rigid hierarchy. Orders flowed down from the platoon leader, and subordinate tanks acknowledged by maneuver rather than speech. Command tanks, identifiable with multiple antennas, became critical single points of failure. When they were knocked out, entire platoons often lost cohesion. Against American forces, where every tank could transmit, receive, and assume command if necessary, this vulnerability became deadly. The Battle of Kasserine Pass, fought between February 14 and 24, 1943, was tactically a German victory. Yet it revealed something profoundly troubling to German observers. Scattered elements of the U.S. 1st Armored Division maintained coordination across vast stretches of confused terrain. Crews who had never met coordinated movements warned each other of ambushes and called for artillery support through crystal-clear FM communication. German signals intelligence units intercepted American transmissions and were struck with their clarity. Reports from the 10th Panzer Division noted that American units maintained communication at ranges where German radios produced nothing but noise. Most disturbing of all was the realization that every American tank seemed capable of full communication, not just designated command vehicles.
The technical limitations of the FUG-5 were fundamental. Operating on amplitude modulation in the 27.0 to 33.3 MHz range, its 10-watt transmitter could reach 2 to 3 kilometers only under ideal stationary conditions. Once tanks moved, range often collapsed to a few hundred meters. Every electrical impulse became interference. No amount of training could overcome physics. When American armor moved into Italy in September 1943, the mountainous terrain should have negated radio advantages. Instead, FM technology became even more decisive. Multipath interference in valleys crippled German AM radios, while the SCR-508 handled it with relative ease. American tanks coordinated movements across ridgelines where visual signaling was impossible. During the advance toward Monte Cassino, German radios often failed entirely, while American coordination remained routine. By June 6, 1944, as Sherman tanks rolled off landing craft onto the beaches of Normandy, their radios maintained contact with naval gunfire support, a level of coordination German technology could not match. The bogage fighting that followed revealed a remaining gap. Tank radios operated on different frequencies from infantry radios, making direct communication impossible. German infantry armed with Panzerfausts exploited this weakness, approaching tanks unseen, while nearby American infantry had no way to warn them. The solution was elegantly simple. Tank crews mounted EE-8 field telephones in armored boxes welded to the rear of tanks, wired directly into the internal intercom. Infantrymen could pick up the handset and speak directly to the crew inside. By Operation Cobra in late July 1944, this improvisation had transformed tank-infantry cooperation.
Operation Cobra, fought from July 25 to 30, 1944, showcased the full potential of American radio superiority. The U.S. 2nd Armored Division coordinated over 200 Sherman tanks through radio networks that enabled unprecedented control. German defenders from Panzer Division faced an enemy that seemed almost omniscient. American tanks reacted instantly to threats reported miles away. Artillery strikes arrived within minutes of target identification. Panzer Lehr, once among Germany's finest formations, was crippled by communication poverty. Many of its tanks operated without radios at all, relying on hand signals in terrain where visibility was measured in tens of meters. The irony was bitter. Germany had pioneered radio use in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on radios in tanks since the 1920s. His 1937 book Achtung Panzer emphasized communication as the lifeblood of armored operations, yet by 1943, German industry could not supply the radios his doctrine demanded. Production figures told the story. In 1943, Germany built roughly 5,700 medium tanks, but produced fewer than 2,000 full transceivers. Most went to command vehicles, leaving ordinary units starved of communication. Soviet forces suffered even more severely. The T-34, despite its reputation, often entered combat without any radio at all. Flag signals and pre-planned maneuvers dominated early Soviet doctrine, with disastrous results in 1941. Lend-Lease American radios eventually equipped some Soviet command tanks, but even by war's end, only about a quarter of Soviet tanks carried radios. Against this backdrop, America's achievement stood alone. 100% of its tanks carried sophisticated FM communication. Motorola's Chicago factory embodied American industrial mobilization. Before the war, it built car radios. Wartime production demanded a complete transformation. Each SCR-508 required thousands of precisely manufactured components. Crystal oscillators had to maintain frequency stability through heat, cold, and violent shock. By 1944, production exceeded 24,000 units annually. More than 50,000 tank radio sets were built during the war, enough to equip every one of the 49,324 Sherman tanks produced. The advantages extended beyond FM. Crystal-controlled tuning prevented frequency drift. Dual receivers allowed constant monitoring of multiple command levels. Integrated intercom systems meant every crew member could instantly alert the commander. Noise-canceling headsets and throat microphones made shouting unnecessary. Power supplies filtered electrical noise instead of amplifying it. German crews often lacked even basic intercoms, communicating by touch or yelling. These capabilities reshaped doctrine. American armored units adopted flexible combat commands, forming task forces on the fly. Such flexibility baffled German commanders, whose rigid structures were dictated by limited communication. In September 1944, near Aracourt, the U.S. 4th Armored Division faced German Panzer brigades equipped with technically superior Panther tanks. Yet radio coordination proved decisive. Over weeks of fighting, American units destroyed hundreds of German vehicles while suffering a fraction of the losses. German intelligence never fully grasped what they were seeing. Reports attributed American coordination to training, not technology. They continued to target command tanks, unaware that every Sherman could command. Even late in the war, German assessments failed to recognize the depth of the gap. By March 5, 1945, as American forces crossed into Germany, communication superiority reached its peak. The capture of the Ludendorff Bridge at Remagen demonstrated command and control at unmatched speed. Reports traveled from frontline units to Army headquarters in minutes. German forces reliant on telephone lines destroyed by air attack could not respond. At the Ruhr Pocket, American radio networks coordinated a massive encirclement that trapped over 300,000 German troops whose communications had collapsed. For American tank crews, radio connectivity meant never being truly alone. For German crews, isolation was the norm. Otto Carius later described the strain of fighting blind, though even he understated the role of communications. After the war, technical intelligence teams confirmed what experience had shown. German tank communications lagged years behind American systems. Post-war armies took note. The rebuilt Bundeswehr prioritized radios in every tank, explicitly citing wartime lessons. The story of Sherman tank radio superiority is not about gadgets. It is about a fundamental shift in warfare. The Americans did not build the best tank on paper. They built the best connected tank force in history. Each Sherman was not merely a vehicle, but a node in a living network. Armor and firepower mattered, but information mattered more. By the time German commanders realized what they were facing, it was too late. They had built magnificent machines that fought alone. The Americans built adequate machines that fought together. In the end, invisible electromagnetic waves proved more decisive than steel or high-explosive shells. The lesson endures. In modern war, connection is power. Isolation is defeat. And that revolution began quietly inside a Sherman tank, carried on the clear, steady voice of an FM radio.